Finding the derivative of a function that requires the use of product rule, but also has trigonometric functions within it, can be quite difficult. But even more so when it looks at first glance like you're going to have to actually apply the product rule twice to find the derivative of this function. Well, recently in one of my weekly live streams that I do every Monday night at 5 o'clock Pacific time, I talked about finding the derivative of a function that fits this exact category. And I know that that can be tough, and I think you'll find this very helpful if you struggle with either finding the derivative of trig functions or product rule, or the combination of the two, or both. So if getting a little more practice with all that stuff sounds good to you, be sure to stick around to the end of the video. And if you do get some value along the way, do me a favor and hit that like button down below, please. It's a huge help to my channel so I can keep making more videos like this. But anyway, let's go ahead and jump into the example, and I'll show you how we can do something like this. We're going to differentiate y equals cosine of x times tan of x times x squared plus 1 in parentheses. So this is a little bit of a trick question I wanted to throw in here. There's a couple ways we could approach this. One is going to be much easier than the other. So I wanted to just kind of bring that up. What we could do is we could use the product rule basically when you have the situation where you have the product of three functions, like we have here. We can use the product rule multiple times to find the derivative where we basically want to treat like this three functions, f, g, and h. So like, and I have made a video on that. If you want to check out that video, I'll go ahead and put one of those little info cards up at the top on how to apply product rule multiple times to a function that is the product of more than just two things. However, we don't have to do that here, because let's think about this function for a second. Cosine of x times tan of x, specifically, let's think about that little chunk of it. Think about what tan of x is. Tan of x can be rewritten as tangent of x can be rewritten as sine of x over cosine of x. Those two things are equivalent. Tan of x is the same as sine over cosine. First of all, that's a formula that I would definitely recommend memorizing. Remember that. Because it does come in handy a lot of times to simplify trig type problems. So this is always going to be true, right? No matter what x is. I guess the only case you want to be careful of is it doesn't really matter if you're taking if cosine of x equals 0, because then you're dividing by 0. However, tan of x is not defined at those places where cosine of x equals 0. That's where tangent has vertical asymptotes. Because if you were to think of this substitution here, you would be dividing by 0 there, so therefore it can't possibly be defined. So I guess it still kind of holds up there, but you just want to be careful that it doesn't really help in those specific spots. However, if we want to think of the function as a whole, we can say this is going to be true. So basically what that means is the function we're trying to find the derivative of here is actually cosine of x times sine x over cosine x times x squared plus 1. Well, now look what happens if we have cosine of x times sine of x over cosine x. The cosine x and the cosine x cancel each other out. So actually this function should not be thought of as this thing that we started with. Instead, let's think of it as sine of x times x squared plus 1. So now this is much easier to find the derivative of, because now we can just go ahead and proceed with the product rule, where one of our things is sine of x, and our other thing is x squared plus 1, and go from there. So let's go ahead and do it that way. So we found our f and our g. Now we need to find our f prime and our g prime. F prime is just the derivative of sine x. The derivative of sine x is cosine x. The derivative of x squared plus 1 is just power rule. Bring our 2 down in front. Lower the power by 1. 2 minus 1 is just 1, so that's just 2 to the x. And then the derivative of a constant is 0, so that would just be 2x plus 0. That's just 2x. Okay, so now the product rule, again, is just going to tell us now that we're going to multiply across. So we do the original of 1 times the derivative of the other, the derivative of 1 times the original of the other, and then add them together. So doing that, we're going to get sine of x times 2x. So y prime equals 2x times sine of x. Multiplication, the order can be switched. So sine of x times 2x is the same as 2x times sine of x. Okay. Then we multiply cosine of x times everything in the parentheses here. And like I said in the last example, if you have, adding and subtracting within a specific piece, like g is x squared plus 1, we have this addition here, make sure you keep your parentheses around the whole thing. So cosine of x needs to be multiplied by x squared plus 1 in parentheses. Otherwise, the cosine x wouldn't distribute like it's supposed to. Okay, so now, again, we kind of want to think of where we would go from there. Do we want to factor stuff out? Do we want to distribute stuff into the parentheses? We'll go ahead and say that we're just trying to kind of write this as simply as possible. So I would factor stuff out. But if we look at these two kind of products that we have here at this point, there's nothing in common between them. There's nothing we can actually factor out of that. So this is really going to be as far as we're going to take this, and that'll be the derivative of our original function. Well, I hope you found this video helpful and you're feeling a little bit better about dealing with trig functions and product rule, especially when it comes to kind of a trick problem like this one was. If you did find this video helpful and you want to keep crushing it all term long in calculus, go ahead and hit that subscribe button and that bell icon down below. And if you have any questions on calculus, feel free to join my live stream next Monday night at 5 o'clock Pacific time, and we'll see if we can get your questions answered. If you want to keep learning about calculus in the meantime, just go ahead and click on one of those videos over there. Thanks, and see you on Monday night.